everyone. Happy Tuesday. So today we are going to be learning about indirect proofs, and this is lesson 1-8. So indirect proofs use indirect reasoning in order to show that a statement is true. So what we're going to be doing with indirect proofs is showing that the alternatives or like the opposite explanations are not possible in order to show that the original statement is true. Okay. All right. So to use indirect reasoning, the best way to learn how to do this is to actually do an example. Okay. So our example here is Beth is having dinner with Sarah and one of Sarah's friends, Libby, Kelly, or Mercedes. Beth orders a chicken and spinach pizza to share for dinner. Who is having dinner with Beth? So we need to use indirect reasoning to try to figure out who is having dinner with Beth, and we have to use the information that they gave us. So we know for sure Sarah's having dinner with Beth because we were told that, but we don't know which of the three friends, Libby, Kelly, or Mercedes, is also there with Sarah and Beth. We know that Beth orders chicken and spinach pizza to share for dinner. So this is actually some key piece of information here because this is going to help us eliminate people. So let's look at the friends. So Libby is a vegetarian. Beth ordered chicken and spinach pizza. Vegetarians don't eat chicken, okay? So because vegetarians don't eat chicken, right? Then we can assume that it's not Libby, like it's not her, right? Mercedes is at the library. So Mercedes probably can't be in two places at once, right? If she lives in the world of Harry Potter and has Hermione's little device, maybe, but let's assume that's not true. So Mercedes is not at the library and having dinner with Beth, so it can't be Mercedes, right? And they tell us that Kelly's allergic to mushrooms. So it wouldn't be Kelly if the spinach or if the mushrooms were on the pizza, but we have chicken and spinach pizza. There's no mushrooms in it, right? So then we can assume that Kelly is the one that's at dinner because it can't be Libby unless, Beth is a jerk and ordered chicken, which we're going to assume she didn't. We're going to assume Beth is a nice person and wants to make sure everybody eats. And it can't be Mercedes because she's somewhere else. So we're assuming that Kelly, who's allergic to mushrooms, is not having mushrooms because it's chicken and spinach, right? That she's the one having dinner with Beth. So who's having dinner with Beth? Sarah and Kelly are having dinner with Beth. All right, so that would be the answer there. Okay, so try it. Let's do this example number 1. Try it. Go ahead and try it on your own. Pause the video, try it. All right, welcome back. So let's do this together and see if we got the same answer. So this says that a bagel shop gives customers a free bagel on their birthday. Thedo went to the bagel shop today but did not get a free bagel. So if this bagel shop gives their customers a free bagel on their birthday, but Thedo did not get a bagel, that means that it's not his birthday, right? Because he did not get a free bagel. So because he did not get a free bagel, and here it's if it's your birthday, you get a free bagel, right? If he didn't get a free bagel, then it's not his birthday. So we can assume that today is not Thedo's birthday. Okay. All right, so writing an indirect proof by contradiction. So a proof that uses indirect reasoning is called an indirect proof, okay? We use indirect proofs when direct proofs are impossible. So when it's not possible to use the original statement to prove that it is true, we use an indirect proof. Okay, and there's two types. There's an indirect proof by contradiction, and there's a proof by contrapositive. So we're going to look at the proof by contradiction first. Okay, so proof by contradiction, what it does, it takes the original statement, it takes whatever the original conditional is, if P then Q, and its first step is to assume that your hypothesis stays the same, but your conclusion is the opposite. So instead of it being Q, whatever Q is, it's not Q. So you're doing the opposite, whatever your conclusion is. You're saying that the opposite conclusion is the one that's true. Okay. The second step is to show that the assumption not Q leads to a contradiction. So you're going to show that not Q doesn't match what the hypothesis is, or it leads to some sort of contradiction with the hypothesis. Okay. And then the last step is to conclude that Q must be true. So because in step 2 you're showing that not Q, it leads to a contradiction, it shows something that can't be true, then you're going to state that whatever your original conclusion was has to be true because the opposite can't be true. Okay. So I've put an example here. You can pause the video to look at this example. I'm not going to read it to you because you're perfectly capable of reading this. I am going to do one with you. So pause this if you want. I'm moving on to the try it. So on the try it, if you want to try it on your own and then look at my answer, that's totally fine. You can pause it here. But let me go on and do it. So this says that if today is a weekend, then it is Saturday or Sunday. So this tells me to write an indirect proof for each statement using proof by contradiction. So the first thing that I'm going to do is identify my hypothesis and identify my conclusion, because then I need to figure out what my opposite of my conclusion is, right? So if today's a weekend day, then it is Saturday. So my hypothesis is today is a weekend day. Okay, and I'm going to always assume that this is true. Okay, so my hypothesis is true no matter what. Okay, my conclusion is it is Saturday or Sunday. Okay, now for my, just gonna get rid of this. For my indirect proof, sorry. So for my indirect proof, I first need to, look, first step over here. I first need to assume that the hypothesis and the opposite of the conclusion are true. So I'm going to say assume that it is not Saturday. Sorry, I'm having trouble spelling today. Saturday or Sunday. Okay. And if it is not Saturday or Sunday, then what can I say? If it's not Saturday or Sunday, and here's my contradiction. If it's not Saturday or Sunday, then it is not a weekend day, right? Because in order for it to be a weekend day, it has to be Saturday or Sunday, right? This is a contradiction because my hypothesis said today is a weekend day, and this is always true, right? So I'm going to say this contradicts the hypothesis, which states that today is a weekend day. So therefore, today must be Saturday, or Sunday. Okay, and that's my indirect proof. All right, let's move on. So writing an indirect proof by contrapositive. So with this one, we also need to identify the hypothesis and the conclusion because we're going to write the contrapositive. Okay, and the contrapositive switches the P and the Q. They switch places, but it's also going to be the not. So it's not, if not Q, then not P. Okay. The conditional and the contrapositive are logically equivalent. That means that they have the same truth value. So if I can't prove that if P then Q is true, but I can prove that if not Q then not P is true, then that makes this one also true. It makes the original conditional also true. Okay. So the proof by contrapositive is similar to the one before, except that now we're going to assume that not Q is true. But we're going to show that this assumption leads to not P, okay? And that we're able to say if not Q, then P. Like we can show that that's a true statement. And if we can show that not Q, then not P is a true statement, then we can say that if P, then Q has to be true, okay? All right, so here's an example that's completely done for you. I am not going to go over it. You can pause this and read it now. I am moving on to our example 3. Try it. If you've read example 3 already, you want to try it, go ahead and pause here and try it. If not, I'm going to go ahead and show you how to do this. Okay. So we're writing in an indirect proof by contrapositive. Okay. So it says if today is Wednesday, then tomorrow is Thursday. So again, the first thing I want to do is identify my P and my Q. So my hypothesis is today is Wednesday. My conclusion is tomorrow is Thursday. Right? So if today is Wednesday and tomorrow is Thursday, are my my hypothesis and my conclusion. In order to prove by contrapositive, what I need to show, and this is my indirect proof. First, I'm going to assume the opposite, right? So I'm going to go with not Q, right? So I'm going to say assume that tomorrow is not Thursday. So assume that tomorrow is not Thursday. So it can be any other day of the week. We are assuming that it is not Thursday. Okay. If tomorrow is not Thursday, so if tomorrow is not Thursday, can today be Wednesday? It can't, right? So if tomorrow is not Thursday, then today is not Wednesday. It can be any other day of the week, but there's no way it can be Wednesday because tomorrow is not Thursday, right? So because this contrapositive is true, so if tomorrow is not Thursday, then today is not Wednesday, that is a true statement, right? And it's true no matter what. So because, or since the contrapositive is true, then the statement must also be true. Okay. All right, and that is it for today. That is all of our examples. There's all of our examples, right? Yes, that's all of your examples. All right, so that's it for today. If you have any questions, go ahead and contact me. There are also, and I'm saying this for those of you that haven't discovered this yet, when you are doing the problem set, you can also look at the videos that are embedded in the assignment. So if you need some extra help with just like one of the concepts there, you can click on the tools that you have for that question and look at the videos to give you a little bit more explanation or to give you a different example. Okay? All right. I will see you all tomorrow. Bye.